y equals 4 minus 1 over x. Let's have a little look at this one then. The first thing to notice is the 1 over x. As x gets large, positive or negative, this number will get very, very small, won't it? So the y values will tend to the 4, won't they? Because if you put in, say, 100 here, 4 minus 100 is still around 4, isn't it? It's just below 4. And if you put in minus 100 here, 100 here, you get a plus, because your double minuses will make a plus, and you get 4 plus 100. So it's going to tend to 4 as x gets large. So let's put that in as an asymptote then. So I'll just sketch that in here. So there's 4 on that side, and it's going to tend to 4 as x gets large, negative on that side. Now as x gets large, positive, can you see that if you put 100 in here, it'll be 4 take away 1 over 100, so it'll be just underneath. So it's going to tend to 4 from below on that side, isn't it? And similarly, if you put in minus 100 in your mind's eye, the minuses will make a plus, and you get 4 plus 100, so it'll be just above. So you can see that as x gets large, negative then, it's going to tend to 4, but from above, just a smidge above. So let's write that down. As x tends to infinity, then y will tend to 4, but 4 from below, so I'll put a little minus there to denote that. And as x tends to minus infinity, y tends to 4 from above, wasn't it? So we've got those two characteristics of the curve. Now let's have a look at another area that's of interest when we see curves like this, and that is when x is 0, because you get 1 over 0 is undefined at 0 when x is 0. But it shoots off to large values, doesn't it? So if you put a 0.1 in here, then you'll get 1 over 0.1 is 10. 4 minus 10 is minus 6, so at 0.1 it's minus 6. If you put 0.01 in here, you'll get 100, won't you? 1 over 0.01 is 100. And you get minus 96. So can you see again, what's happening here is it's shooting off to minus infinity as x gets smaller that way. So let's have a look on this side of 0, which is another point of interest, because this is where this changes here. So if you, in your mind's eye, put x is minus 0.1, the minuses will make a plus, and you'll get 10 here. 4 plus 10 is 14. And if you put x is 0.01 with a minus, you'll get plus 100 here, won't you, in your mind's eye? And you'll get 104. So as you get closer and closer and closer to 0 from below, it will shoot off to infinity there, won't it? So this looks like the way the curve is. It's going to swing from here down to here, and it's going to swing down from here through to this value here. So let's just put the other things we mentioned. Also, as x tends to 0 from above, y tends to minus infinity, and as x tends to 0 from below, y tends to plus infinity, wasn't it? So this is the information that we have. So let's try and do a little sketch then. I'll just get rid of these little things I've just drawn in at the moment and try and do a better sketch now. So I'll try it with the digital pen, see how we get on. It comes down there and swings down there to infinity, and it comes from infinity here and swings down and tends to 4 as it gets negative. And this is the curve. So let's label it y equals 4 minus 1 over x. So I'm just going to jot that down on the plotter. On the tools bar, you'll see there's a plotter. So let's just get that then. We want to type in 4 minus 1 over x. 4 minus, and let's see how the plotter does it, 1 over x. I've done from minus 10 to 10, and then we'll generate the plots. And you can see here, it doesn't show the asymptote explicitly here, drawn in or anything, but it is there at 4, isn't it? Which is what we had. And we've got this characteristic shape. The other thing to denote is that the y dx is only tends to 0 here, doesn't it, and here when it flattens out. So we could actually look at that just to verify that. So why don't we just finish off with that little point. Note. Let's just do a little note. Y dash then differentiate. It's easy to do. Constants go to 0. This is equal to x to the minus 1. So when we differentiate, we get a plus. X to the 1 less power is minus 2, which is equal to 1 over x squared. And we know that this is greater than 0. for any value of x. It tends to 0 as x gets large. So, as we said, there's no turning points on this curve.